All right, folks, now that we've gotten past the syllabus, we are going to start looking at some of the hardware and software tools that we need to use to be successful in this course. Um, so I'm just going to click on this little entry. I just put this entry together a little earlier today. I borrowed a little bit from my other school where I teach Python pretty regularly. And I have some just kind of general tips here, and none of these are rules, by the way, right? The reality is Python, because of the way it's designed, really can run on just about any type of computing device. That includes phones and tablets and even like game systems and weird stuff like that. However, those are not ideal environments for coding, right? What my strong preference for you would be is that you have a full either laptop or desktop Windows computer or Macintosh computer. Those would be the two primary platforms. And I do indicate here that they should be modern. So like if you have a Mac from 2005, it's probably going to be hampered a little bit, and when I say modern, I'm thinking within the last 3, 4, 5 years, ideally. If you're working on a Windows or a Mac machine, the memory requirements are roughly similar, but not exactly the same. Anybody who's familiar with the new M series of CPUs from the Macintosh, they are getting away with real low RAM counts. And I just picked up a MacBook Air a while ago. Actually, I have a couple of them. I was just blown away that how much I could do with 8 gigs of RAM. And I'm like, oh, this is going to be horrible, and it turned out to be just the opposite. It's because of the way the architecture of the chips operates, you can get by with more. On a Windows machine, I'm going to say really a functional minimum for coding should be 16 gigabytes of RAM. You can get by with 8, right? But 16 gigs should be your minimum. If you're on a Mac, you can easily do work on an 8 gig system if you're on an M chip, so M1, M2, M3. If you're on an Intel chip, you probably want to be 8 or 16. 16 would be preferred, right? The Intel chips now for Macintosh are getting a little bit aged. You also want to be on a recent operating system. Okay, why? Modern operating systems are more secure. It's really as simple as that, and they're not really that much different than the older operating systems in cases. So the ideal would be a modern Windows or Macintosh machine. In terms of hard drive space, anybody who's coded before knows that it's really easy to fill up a hard drive if you start installing a bunch of powerful software for coding. If you install the full-blown Visual Studio, not Visual Studio Code, right, but the full one, that can go up to like 120 gigs of hard drive space. It's kind of like installing like Battlefield or something. It can be very hard drive consuming. So plan ahead, right? The tools that we need for Python are not very space consuming, but they can be resource consuming. In other words, they can have a large memory footprint and grab a lot of CPU and processing power. And because you can write code that can, for example, create an infinite loop, you can get things locked in memory too. So it's generally speaking, a coding machine should probably be about as powerful as a gaming machine. If you want like a basis of comparison, or maybe a machine that you would use for graphic or video arts, would be the type of level of machine you want to use. If you're shopping for a machine because you're learning how to code, I would go 16 gigs of RAM, minimum 500 gig hard drive SSD, the fastest, most modern multi-core processor you can afford, and a high-end graphics card. All of those things. And because it's you're doing it with your eyes, as big a screen with a high refresh rate as you possibly can get. That's my general recommendation. For coders, it's really, really important because when you spend the whole day looking at a screen, it really wears on your eyes, you guys, right? So get yourself, it's kind of like having a good pair of glasses. Get something decent that you're looking at. Get a really nice high-end monitor, or high-end laptop, or whatever it is you have to do to make yourself comfortable. If your eyes are straining from coding, that's a pretty good indicator that you probably want to upgrade. Another thing that I do recommend, and this isn't a requirement, but it makes it a lot easier when you're doing a Zoom session like this, is to have more than one screen. right? Now you can do that a couple different ways. One way would be you take your laptop or your desktop. A lot of those machines have auxiliary monitor ports on them, and you don't have to run out to like Best Buy and buy like a $300, $400, $500 monitor. You can actually run down to Goodwill sometimes and buy somebody's thrown away monitor and use that for a second screen, right? You can put Zoom over there and do your coding on the other screen or vice versa. Um, if you can afford a better one, do that. Another way to get a second screen, so Mac users know this, like you can second screen to your iPad if you have an iPad, right? So Macs, as long as you're on the same Wi-Fi network, you can do that. Or you can take a tablet or a phone and set it next to your computer and use that as your second screen, and maybe that can be your Zoom tool, and the other one can be your coding tool. I just say this because it's really helpful to have the ability to look at what you're being presented and then being able to work on the screen at the same time and not be constrained by space. All right. And I see Cody dropped in his specs, and Cody, you're outing yourself as a computer nerd, right? when you so readily know your specs, you're putting them up on the screen. But yeah, you know what? Yeah, you can get some really decent machines now for not a lot of money, especially Windows machines. And the Mac people always hate this, but you can on a PC in principle get a lot more for your money for a lot less money. I do also get the people who get a little bit kind of like let's say biased against Macintosh, especially in coding worlds and in the IT industry. And I would strongly encourage you, if you have that mindset that Macs are junk and they're way too expensive and they're too proprietary and all that, you know, people that typically say that are people that have never owned and worked on the platform. Macs tend to have a longer life than a PC. Every Mac that I've owned, I've used for at least 10, 12, 15 years before I've gotten rid of it. Can you say that about your PC? And then at the tail end of the life, I was able to even sell them for a lot of money in the aftermath. Yeah, but they are a lot more expensive. But at the same time, their operating systems and their closed development system, you get a lot more throughput on a system with a lot less specs than you do on a PC. Often the weak point on a PC is the system board, right? You have a great video card, but your system board is horrible, that kind of thing. And that bottlenecks your performance. So don't be biased against Macintosh is what I'm trying to tell you. Be open-minded to it. What I do not want you guys to do, right? And I know some of you guys might start here, is don't try to code on your phone or a tablet or a Chromebook. It's not that it's not possible. It's just very not recommended. And you will find it very constraining very quickly, right? If you need to start on one of those devices, do that. If you are in a situation where you don't have the equipment that you need, you can talk to the people at WCTC and they might be able to hook you up with something. Or worst case scenario, you can go on site on campus and find, go into one of the labs or library or whatever, find a machine and work there, so don't sit constrained with bad equipment. All right. Software requirements. The first thing that most of you will want to do, and normally I don't say download the libraries first, but it might not be a bad idea to do this, is to follow this link here. We do need to have the Python 3 libraries. So if you follow that link, you'll end up on this website. You'll notice this is the official Python language site, python.org. We are on the downloads page, and you can see right here at the top that you can just click that button. That will pull down. I'll go ahead and click it even though I've already done it, right? So it's already in my downloads folder. It'll go into your downloads folder. You can see mine's loading up here. Right? Your browser might put it in a different spot. And then go ahead and click on that executable file and follow the instructions for install. I know that most of you are probably familiar with this process, but if this is an alien process to you, I can help you like maybe during one of the breaks to make sure that you're doing it correctly. But what this will install are the core libraries for Python. So the libraries that we need to both run Python programs and to create the code to create Python programs. So it's kind of a combination. Are there other Python libraries that you can install? Yeah, this installs kind of the base set of Python libraries, and there are a whole bunch of them that can be added on. There's tools that are built into the Python language for adding libraries. If you run the native libraries, we have this little tool called pip that you run at a command line where you type in commands and you can add libraries. If you instead go with the Anaconda distribution, which might be preferred for a lot of you data or AI people, they have a graphical tool that allows you to manage that. And I actually prefer that. I think it's just easier to use rather than looking up little pip commands. You won't need to do any of that, by the way, for this course, right? That's just auxiliary information. So make sure that you go ahead and download it. You will notice that they have versions for Windows. It should auto detect your operating system. So right now it's detecting I'm on a Windows machine. So it's giving me the Windows download. But if you are on a Linux or Unix machine or Mac OS or God forbid something else, they have libraries for it. So you can do those downloads. Generally speaking, almost everybody. Yeah, so now I'm getting questions about this. So should I disable the path length limit? Okay, so from a practical standpoint, Thomas, I would say yes, right? Because if you're putting Python somewhere obscure on your hard drive, and then you can actually run out of path length and then not be able to work with any of your files. So yeah, disable that. No harm done, basically. Right. I've run into that problem in the past, and it was a very annoying problem to overcome. All right. So this is where you get your Python libraries. I'm going to go back now here and talk about this a little bit. I would call this a first step, but what I will say is if you decide to install these two options, which we're going to talk about shortly, the installation tools for these two products will install Python for you, right? Right. The one reason that you want to do it this way is this will install the latest version of the Python libraries, where sometimes those other two tools will not. And I was checking that earlier because I'm running the Anaconda distro, and I haven't updated it since fall, I think. And I was noticing, I think it was on version 3.8, and the current version is 3.12. And I thought that was kind of fascinating. So that's why it's a good idea to do this first, because then if you install these two items here, whichever one you choose, instead of using its more antiquated version, it will use the new version, right, which makes sense. Generally speaking, whenever you're installing stuff like this, if they have like beta versions or trial versions or experimental versions, do not download and install those. Those are meant for people that are building the language. Always go, and this is kind of like Linux speak now, by the way, always go with the latest stable version, or often you'll see it marked as LTS, long-term support. That means, yeah, this one works. We'll even support you on it because we know it works, right? If you're looking at betas and experimental versions, just generally stay away from those unless you know what you're doing, right? Because you might have very unfavorable results otherwise. All right, so, and as I say here, the Python libraries have to be installed in your system in order to either be able to code Python or run Python. Some of you might already have it, right? So I have a couple of software packages on my machine that require Python to run. And you might have the same situation going on. All right. Let's move down now to the coding environments, and let's talk about terminology at this point, because coders, and I'm just kind of telling you this politely as somebody who's coded for a while. Coders often do something to see if you're in the know, right? They'll throw acronyms at you or like weird catchphrases, and they're able to tell right away if you know anything about what you're talking about by just, like, for example, one of those acronyms is IDE, right? And what that stands for, by the way, and I think this is important terminology, is an integrated development environment, meaning it gives you a tool to write the code, a tool to make sure that the code is correct, and a tool to run the code all within the same software package. So the writing, debugging, and executing of the code is integrated into one development environment. So we call that an IDE, right? And so if you talk to a coder and they go, hey, which IDE are you using? And now you don't have to give them a blank stare, right? You can answer intelligently and say, well, I've experimented with several IDEs. You know, you can kind of throw it right back at them. And whenever we hit these like points as we're going through this material where we have important terminology, I will make sure that I highlight it for you because the words you use are important, you know, because they have very specific meaning in coding. All right, let's talk about the IDEs that I have listed here. First of all of them have no cost with the exception of PyCharm, okay? And that's with an asterisk, all right? I know that our software department here at WCTC prefers and generally recommends the use of Visual Studio Code. A lot of young developers prefer this tool. It's really popular. It's not been around a very long time, but it's one of these, what I call extensible environments. So it's kind of like an open source platform. It works on all the operating systems. You can run this on Mac, on Windows, on Linux machines. And it has a gazillion extensions that you can add thanks to Microsoft. This is a Microsoft product, by the way. Very weird that they released one that's free, but they've had such an impact with it, right? You know, and this is kind of, I'm going to call this the child product of their big IDE, which is called just simply Visual Studio. And ultimately, if you guys are really a professional coder in anything Windows or Microsoft related, Visual Studio arguably is probably the singular best IDE. It is available for free also if you get the community version. The pro and enterprise versions cost money, and big money at that, but often are the preferred tool of choice. I do see a lot of people coding with Visual Studio Code, and if you want to download this product, just simply follow this link. It'll bring you to this website here. And download the version that's appropriate for your operating system. It should auto detect your OS, you know, so if you're on a Mac, it should say download for Mac OS. If you're on, you know, like Ubuntu or something weird like that, it should say download for Linux. You know, that should be fairly automatic. So go ahead and click the download link and pull the product down. I already have this installed, so I'm not doing a demo on it. The screens are pretty self-explanatory. Once you have the product downloaded, I will show you how to add the Python libraries. And I think we're reaching a really good spot right now to take a break, because that will give you a chance to both download this product. I think for most of you, this might be the preferred tool of choice. If you're not sure which tool you want to use, it does not hurt to download all of them, right? No harm done, as long as you have the hard drive space for it. So go ahead and do the download on this. I'm going to pause the video and we're going to go into a break. And then when we come back, we'll talk about the next step. So the video. So we're back from break, and hopefully some of you tried to do the install on this. And if you got to the point where you have the product up on your screen, right? You know what? I'm going to launch it cold, you know, so I'm just going to go to my start menu here because I already had it up and running from earlier in the day. And I'm going to collapse my panels here. And you see I have files already open inside of here. But normally when you get in here, you usually get a welcome screen. You can close that welcome screen. What I would like you to pay attention to, though, is if you're going to code in Python in this environment, it's not a given that it just works and you have an IDE. Visual Studio Code, I call it, you know, for lack of a better example, kind of like the Swiss Army knife of coding tools, meaning it's capable of doing just about anything, but sometimes you have to add little gadgets to it to make it do the stuff you want. And so here in the sidebar, they have this little tool called the extensions panel. And I want you to click on that. And what I want you to do is just right up at the top here, type Python. And what it'll do is it will load up Microsoft's default set of tools. Now you can see for me, it's already installed because I don't have a little blue button. But what we're looking for is the Python language support from Microsoft will be a little blue button on that panel. Just click the install button. That will go out to the web, download the required components, and add them in to Visual Studio Code. If you've already installed the libraries, it will utilize your already installed libraries. If you had not, it would go through the process of installing those as well. I do prefer it the other way around though. I like the libraries first because you get the latest stable version, and then you add the Microsoft language tools. And this will basically add tools that will allow you not only to compose the code and color code it so you can see your errors, but it will do things like what we call IntelliSense, which is help you auto-complete your code. It will underline errors. And then when you hit the little run button, it will execute the code as well. I'm going to give you guys a couple moments to do that. But as you're doing that, I am going to shift gears here. Now, if you feel like I'm moving too fast, that's okay, because I know most of you will probably use this tool as your preference. Maybe it already is your preference and you already have it installed. But I want to talk about the other tools as well because they're important. So let's go first back to this little entry here. And I want to talk about the Anaconda distribution. And you'll notice that there is this link here. Right? And I'm going to go ahead and click that and talk about this. And Anaconda is not what I'll call an IDE. We call this a distribution, which means that it's a collection of software packages and tools designed to enable you to do certain types of work. And you will notice, what is the focus here, right? It's data science, data analytics. And by the way, if you guys aren't aware of this, Python is also the primary language for coding AI, which I think is really fascinating, both to create the AI itself and to run software within the AI. It's, for whatever reason, really well suited to the task. But the Anaconda distribution is really designed for data scientists. And what it gives you is not only the data science libraries that we typically use and libraries for AI, artificial intelligence, basically machine learning, natural language processing, computer vision, and all these really like out there kind of concepts, right? And they're all built in. It gives you not only the language libraries, it gives you a few different coding tools. And the three primary coding tools that are built into the Anaconda distribution are the Spider. This is Spider not with an I, but with a Y, IDE. And that's kind of a normal-ish IDE that's designed for Python. I use that one a lot with both my high school students and my regular college students. That's kind of our preferred tool at Gateway when we do intro level courses. It has another tool built into it called the Jupyter Notebook. And once again, that's not spelled in the typical way either. The first I in Jupyter is a Y, so for whatever reason. And it's a little bit different type of IDE. It's browser based. However, it's an installed piece of software. So it runs in your own machine, but it runs through your web browser. And it gives you both the coding environment and output on the same screen. And it also intermixes with markup so you can create documents and presentations with it. That Jupyter Notebook tends to be the preferred tool for data scientists and people developing AI and machine learning solutions. It does lack some tools though, which is why I'm not a fan of intro level stuff with it. And the tools that it tends to lack are things like autocomplete, IntelliSense, and code and syntax error highlighting. So it does, like if you make a mistake, it doesn't show you until you run the code. Right? Not really good for intro level. But it has another tool inside of it called IDLE, which is the default IDE for Python. Not a fan, but it's in there. Like if you download the language libraries directly, IDLE's built in and you don't really need to download anything, but I don't like teaching around that tool. It's kind of, in my mind, a little primitive. I just don't like to use it. So if you want to do this one, you can just hit the download button. It will install it. When it gets installed, it will give you this interface. And I'm going to show you what that interface looks like. So it's called the Anaconda Navigator. And you see it loading up. And really what it is the launch point for a bunch of different Python related tools. And you can see it's taking a while to load up here. So, and there it comes finally. Right? And of course it's not there, but when it comes up on screen, in principle, it gives you access to all of your Python or Python related tools. You can see some of these are already installed on my system. A lot of them are not, right? You don't need, if you do install Anaconda, I just want to just say up front, you don't need to launch your software from here. You can still go right to your menu and launch them. If you decide to run Spider, and you know what, I'm going to go ahead and launch Spider on my screen. And I'm also going to launch the Jupyter Notebook. I just want to give you guys exposure to them really quick so you know what they look like. This is the Jupyter Notebook. This isn't really a good example, but for example, I'm just going to open up a little exercise. So this comes from one of my classes over at Gateway. This is what the interface looks like. So you code in the window, and then you see the output here. For whatever reason, this is the preferred tool of data scientists. I think it's pretty weird, right? The Spider IDE looks more like a typical IDE, although it is in a really weird format here, and I'm not really sure what's going on. I've never seen it look like this before. This is really weird. Maybe because I'm I'm running too many other things at the same time. All right, go back to the so this is what the default layout looks like. Like I said, this is the primary tool I use for intro level teaching. I like it a lot because it does all the things you expect in an IDE, which is color coding, error demonstration, and you can run your output here, and you can monitor your variables up in this window. So I like this tool. This is a good tool. And it's free. It's part of Anaconda. I'm going to close both of those tools though, because like I said, I'm not going to be starting with those tools here today. I'm going to close the Anaconda Navigator. And then let's see if my Jupyter Notebook is still running here. No, it's already closed. All right. Let's go back and talk about the last IDE option, which is PyCharm by a company called JetBrains. Now, the thing about JetBrains as a company is they really have some really high-end, excellent coding products that a lot of professionals prefer. There's a however. The however is they cost money, and not a small amount typically. They're very expensive products. Their what I call granddaddy IDE, or their big product, is a product called IntelliJ, which was built to code in Java, but it's capable of really supporting just about any language out there, right? With the right plugins. They also have specialized IDEs for very specific tasks. So for example, PyCharm is an IDE built for doing Python. And yes, you can download it and do a trial version of it. There's a free community version of it too. So if you want to try that, what I suggest, and I list this in the instructions, is that before you download, it's smarter to do this. Click on education and come up here where it says for students and teachers. Click on that link and then sign up. They have a little link here somewhere. Where you can apply for a free educational license. It may be automatic. And so like, I forget who put it in the chat that you didn't get an email back right away. I know when I do it at Gateway Technical College in Racine, we're on their list somehow, and it's like automatic. It's like you get the license key immediately. Once you have that license key in your hand, then you come back and download the product, and that key will unlock any of their products. You do have to renew annually, though. That's kind of the catch. I would, if you're brand new to coding or you don't want to go through all that hassle, I would stay away from this for now, but just put it on your radar as a tool that a lot of Python programmers do like and prefer. If you've already coded before, you might already know about JetBrains products. They are very, very slick and powerful, by the way. The final option, and I'm putting this one out there, if you have the unfortunate situation, maybe you're on a Chromebook and that's all you got right now, right? But you still need to code for this class, or you are having difficulty with the install of any of these products, or it's not working quite right. This final option is the one you want to exercise. And this is just very simply a web-based free IDE. It has its issues, right? One of the issues is saving or downloading your work is kind of an issue. It doesn't really work very well on a lot of people's browsers, by the way. Sometimes the code is seen as malicious when you're trying to download it. So in a pinch, what you do is you come into the coding window, copy paste it into somewhere else, and then submit the file. But what's nice about this environment, and I'm just going to kind of blow away the code that's there, right? So let's just delete all that, is I can do something really simple like this. And by the way, that's the very first program you're supposed to write, is hello world. But what the beauty is, you can do it right in your browser. You don't have to install anything. And just about, not, I'm not going to say all, but just about all the stuff we're going to do in this class will work in here, right? So in a pinch, you know, if your computer's not working, your software's not installed right, here's a tool you can use, right? For those of you that are in the know, this isn't the only tool like this on the internet. There's a whole bunch of them. I just like this one real simply because it's free. There's no ads. It works generally. You know, I say generally with an asterisk. It can be a little buggy, but it's there, right? So like if you have no other option, this might be a good one for you. Now, this is important because we're about to go into like coding here and talking about the language. So you need to have one of these tools available and in your arsenal. What I'm going to do now is I'm going to end this video. I think that's kind of enough about installing software, and I will field questions for a little bit, but then we're going to get into the materials. So this video will end here.